We're live everywhere. Hi, chat. Hello. Welcome to the stream. It's Thursday. You know what that means, chat. It means it's a real good stream. Welcome back for another real good stream. Thanks so much for being here. If you're on my channel, appreciate it. If you're on the Real Good channel, appreciate it way more. Twitch.tv/RealGoodAI. TikTok.com/RealGoodAI. Probably. YouTube. Real Good AI. It's out there. We're streaming everywhere. We're live everywhere again today, chat. We should have shared chat on, so we should all be in the same party together. And we're watching, so if you have questions, which I imagine you will, you should ask them, and we will address them. We will see those, and we will try and work them into the stream. It's not just me today. Oh, Amen left the video. Okay, we'll fix that in a minute.
Yeah, maybe vamp a little bit more. Amen seems to have absolutely hung up.
There's supposed to be 3 other people here. One of them's Dr. Mandy, obviously, you know her. The other person who is supposed to be here, who I'm sure will be back any second, is Dr. Amen Gomiri, a staff researcher at Real Good AI. You have heard from her many times, asked her many questions, and today she'll be interviewing friend and colleague, Dr. Brandt Belson. Should be clear, friends with Amen. This is my first time meeting Brandt, but Dr. Brandt Belson is here to graciously share some of his time and some of his experience and what he has done. And we will get to that in a minute. Amen is going to be leading the discussion. So when she gets back, I'll hand it over for her to lead. But, I should tell you, I'm going to be playing hockey, chat. I know, it's been a while. You haven't even seen this player because it's a new game and a new player since the last time I played NHL for you. But we have a new generation of and friends making his name. I think I'm playing forward, so there'll be lots of goals. It's going to be really good. And it looks like Amen is back.
Yes, sorry.
Oh, good?
Mix up. So did you do the introduction or should I start it?
I did everything except to say that now that Amen is here, she's going to lead the discussion and introduce our guest, and I'm going to hand it over to you. Go ahead.
Okay, so hello everyone. Hello chat. And today we will have a very interesting conversation.
Wait, can we pause? I think we're not live on the channels properly, Bob. Sorry to do this to you.
Which one?
Oh.
There's 5 of them.
Twitch and TikTok.
I see us live on TikTok and live on
YouTube
Twitch.
died too. It streamed 7 minutes ago, so it ended. Yeah, it never got us talking, just the starting screen.
Yeah, Twitch as well. I don't see us. Yeah.
Lovely. It was
starting
live.
soon.
Try again.
Yeah, it's not on TikTok either. He died.
So I don't push any button. Tell me what should I.
No, Amen, stay here. Just stay there.
Oh my god.
Well, if you're here on my channel, you still get to see. But let's see. Let's see if I reload OBS. Start it all over. Just magically work, probably, right?
Sometimes this is the easiest way.
B. It thinks it's working again. So, you know, for whatever that's worth.
It is, so we can start.
It looks like it is. We should just talk really fast before it all breaks again.
Okay, so I'm assuming that the Twitch and everything is working great. So let me introduce Brandt. So Brandt and I went to grad school together. So I know him since grad school. His background is mechanical engineering, so focusing on control, fluid flow, and we can go back to it after. So after grad school, we had kind of like a very different paths where I pursued academia, but he pursued industry, and specifically machine learning AI industry. So Brandt worked across a bunch of startups using AI and data in different ways. And what I wanted to do today was the audience kind of like an interesting path of what he did and explain the different like positions and jobs that he had, and also how it was like what are the skills he used in order to do it. Because correct me if I'm wrong, you're not a computer science person, you're an engineer.
Yeah, that's right.
Yes. So hello, and again, can you start by explaining what science and research you were doing back in the days?
Well, yeah, first off, thanks for inviting me on. And yeah, my science and research in grad school was simulating, controlling, and modeling fluid flow, in particular, try to reduce turbulent flow in the boundary layer. So it was a lot of math, a lot of software, and also a good bit of just understanding sort of the physics of fluid mechanics.
The fluid mechanics, okay. So at that time, I would say it was 2013, if I remember correctly.
Right,
Yeah.
that's when I graduated.
Yeah. So at that time, machine learning, we didn't hear much about machine learning, right?
It's true. Yeah, yeah. As I was through most of my PhD, I was not thinking about, I was going to do machine learning after I graduated. But as sort of got closer to graduating, it started to pick up. At the time, most people just called it data science. Now I feel like there's, data science still exists, but people often call it machine learning engineering or AI. But yeah, at the time it was more just called data science. And I got more into thinking about that and thinking like, what do I really like? Do I really like the physics and the fluid mechanics part? Maybe I should, get a job in that, or is it more like the modeling in general that I like? And I kind of thought it's more the modeling. I could enjoy that applied to a lot of different kinds of problems.
Yeah. And we kind of did kind of machine learning, because I remember, so our control systems had a model of the systems with input and outputs and a reduced order model and all these things that we were doing it in engineering, which kind of is what the engineering AI do, right?
Absolutely. Yeah, we were, in a sense, we did data-driven modeling. We would run a large simulation, collect a lot of data, and then find a simpler representation of it that we could use in control tools. So it was very much like machine learning, a lot of the same math involved. Yeah.
Yeah, yeah. Okay, so after this engineering path, what was the first job you got out of school? Because this is interesting. You chose something that is not at the first, when you say it, it's not really sciency, but I'll let you explain.
Yeah, it was a fun. So I really like sports. I've been into sports my whole life, in athletics, and first job was at a very small early stage startup doing sports analytics. So we originally started working with the NBA, in particular the Warriors in the Bay Area, and they had at this time just started to collect this really cool new kind of data, which is the locations of the players on the court, and how they're moving around. And from that, no one knew exactly what to do with this yet, but it was really interesting data. And so this little company started basically to figure out, what can we do with it. And we first sort of created, first had to clean the data because it was at that time not all that clean. No one had really tried to use it yet. So there are all kinds of little eccentricities with it. And then identified what was even happening. Yeah.
So
Yeah.
first, what type of data? I'm very interested.
Yep.
So you have this sport. So it was data from the Warriors players?
It was the whole NBA. We were working specifically with the Warriors first. Yeah, so we had all the games. Yeah,
Okay, all the games with the Warriors included into them or even not included?
not every game, not just Warriors games. Yeah,
Ah, so you want to analyze the players of other like adversary teams. Okay, and what
yeah,
kind of data? So tell us more.
yeah. Well, good. We've got some sports, this hockey going on here. If you can imagine each of these players going around, like imagine just a single dot for each one at something like 20 times a second. We would have a dot for every player for every moment of the game. So that was the raw data.
The
Do
raw
you
data would
know?
be the location?
Yeah, locations like just X, Y, just like 2D locations on the basketball court. We also had sort of the associated data of like a basket went in, the score, the time left in the game, things like that. But it was mostly this location data through time. Yeah.
Bob, you want to say
Okay, so
something?
I have a
Well,
sort of
I was
technical
just curious.
question.
Do you know how that was collected?
I'm
Yeah.
I
not.
know.
So
I know you
different
didn't do
sports were,
that, but
yeah. No, we had to, it was important how it was collected because, yeah, like I said, some of the data was not all that clean at the time. So uh, for the NBA, I don't know if they still do it this way, but back then it was all computer vision based. So they had arrays of cameras in every arena that were tracking the players' numbers on the back of their jerseys, and that's how they identified which player was which. And yeah, so I mean, because it was computer vision, you could kind of expect where it might not do so well. So like when there were crowds of players and you couldn't see the jerseys, things got a little bit mixed up. But yeah, that was the source.
interesting.
Mandy, you had a question.
Yeah, sorry. I was just gonna ask because this was like the high times of like GANs, right? And this is a really technical question, but you probably did you generate and pretend to play a bunch of characters or yeah, essentially.
That would have been a lot of fun, but we didn't sort of generate new games
Oh
or like new
man.
strategies or
Okay.
anything like that. But that would have been good.
I
Yeah.
have, I have
What's
another
a
question. Go ahead.
What's a can? I'm a normie.
Generative adversarial network. So it's a way to create
Oh,
new synthetic data. You basically train another model. I can get more into it if you want. Basically, you train another model which generates data that looks like the original data but is new, and you can even prompt it in certain ways to sort of conditionally generate certain kinds of data. Like maybe I want a play where the player makes a 3-point, basket from half court. You can kind of seed it to do that.
oh, cool. Sorry, I know Mandy
Okay.
brought that up. That was kind of just a general question.
So another question about that. So do you link, like, do you follow like the main player? Again, I don't know anything about basketball except Steph Curry, which is the only player I know. But for example, do you follow high leaders in the basketball to kind of track their own performance and kind of like know a little bit about the adversary main players? Like, do you track it by specific like points location? Are you interested mainly, do you put more weight in the location of some main players or you don't care any player around?
We definitely cared about which player was which and who was most likely to take a shot. Um, a lot of the strategies that teams use are to create space and time for their best player to get a good shot, right? So that showed up in the data, and we definitely cared about that a lot. And one of the more interesting, there were lots of interesting things. Like you could see certain players needed more space or not to get a good shot. Some defenders we also analyzed, like and how good they were at closing down the opponents, quickly and preventing them from having a clear shot. Yeah, we definitely focused more on the high impact players. Yeah.
I see. So you said at that time you used like manual features for engineering, like, right? And classical like small models, like
Right.
I'm assuming like logistic regression and stuff like this. So how would you approach this nowadays? How it's your modeling would be different if you're building the same system with today's modern AI, would you do something
Yeah.
different? Like, how would you do it?
Yeah, so at the time, it was a very small startup, like 5 people for most of our existence, and we had to move as quickly as we could, and those simple models were just easy. And we had people who were really knew a lot about basketball, so we had pretty good way to come up with these manual features, but it was still a pretty manual process. We had uh, like thousands of different types of events that we were identifying. So each one of those had its own set of features. I mean, we shared features a lot, but still, each one was unique. I think if we were to do it again with sort of the more modern methods and ideas and all, I probably want to do some sort of pre-training because we did have a good amount of data. And so do some pre-training with cases that are like sort of already labeled, sort of automatically labeled in the data set. And then after we have those like sort of base models, do like fine tuning with a different head for different kinds of events. So we could easily add new events that we wanted to identify just by like, starting from the base model, adding a little extra layer on top, and probably not need a lot of labels to do that.
Oh, that's cool. So again, back to the warriors. What did you give them as outputs? Like, what did you give them? You told them what's the result? And so another question: did they use it and did they win games because of you?
Yeah, there's some things here I probably still a lot of our agreements had to be fairly secretive because it's a very competitive environment. They don't want to know what you know, they don't want the opponents to know what they know about them. So,
Sure.
but we gave them lots of different ways to look at the different events that we identified and like different ways to break them down. Um, and we did not know exactly what they used, and that was intentional. Like if we didn't know, then we couldn't leak it. So, but at least I hope that they used it a lot. I hope it contributed to their success because around that time was when Steph Curry was and Klay Thompson were there and like winning championships. So it's a fun time to be involved. Yeah.
And so you don't know if they use it because they are they using it right now? The models is still like useful for them? Like other teams are doing the same? Like what's the status of it?
It's been a while. So I left in 2017 or so. So I'm not really sure anymore sort of what's going on. I'm sure that in some way or some form they're still using this data and probably some forms of what we came up with. But I don't know for sure.
But it's still
Yeah.
interesting. Like you would not think like machine learning is used in sport. You feel like, sport is
Yeah.
like a game when people are literally playing, but it's kind of like, Moneyball. I'm sure most people saw the movie. So it's like a lot of analytics and machine learning can definitely help with that. That's so cool. That's so cool.
And
Yeah.
that
So
I just want to point out because people always think of now sports and betting, and those are the direct things like
Mhm.
with when we're connecting AI to sports. And this is not that at all. This is strategy and playing the game.
Yeah.
yeah. Yeah, so a couple things. Yeah, so we started off doing strategy. Uh, Later on, we actually started to make content for fans. So our analysis got so sort of end to end complete that we could just come up with automated stories and let fans look at them. So that was it's also a bigger market for us. So that's kind of where we ended up sort of near the end of my time there. But yeah, one of the like Moneyball is a good analogy. In baseball, in some ways, it's easier to analyze. Like it's a very discrete sport. Like there's a pitch, which is a strike or a ball. There's a hit or not a hit. Like it's all fairly easy to represent that data. But in sports like hockey, and basketball, like the players are moving around. It's all very fluid. So like the main thing we had to do first was just like discretize it. What are the events, and then kind of analyze the patterns in those events.
Mm. And you mentioned so hockey. You used your model for basketball, but did you use it for the NFL? Did you use it for other sports? Like what are they? And
Yeah, we
which
did.
team
We did.
hired you? Spill the tea. Which team hired you?
We did use it for the NFL. I don't know. we didn't work on hockey. I don't know what the state is of that kind of data in hockey right now, but yeah, we worked with the NFL. There we did it for sort of team, or sorry, like league wide. We weren't working with a specific team, which has seemed to be the direction the leagues were headed, is they wanted to sort of centralize a lot of this analysis, because a lot of it was not just for strategy. A lot of it is for entertainment. Like, it's to make the broadcast better, to make the supporting content, like news stories they write about the league, better. So leagues were investing, not just teams.
One in this chat say like he heard that the NBA was using also AI to analyze injuries and see how they can prevent it. Do you know something about that?
We worked on that a bit too.
Really?
Yeah. That also was pretty, like, we were sworn to secrecy on that, but yeah, we did work with some teams on preventing injury and analyzing the causes. Yeah.
Okay. So just a parenthesis here. If someone has more questions in the chat, you can please ask it, and then we'll go back to it after. So okay. So after your NBA, NFL career as an AI,
Right.
you kind of switched gears and moved to be a machine learning, like data science manager at Tonal. And I don't know if many people know Tonal. So can you Tonal or Tonal? I don't know how you pronounce it.
First one's right, tonal.
Okay, Tonal. Okay, so can you explain? It's kind of linked. I see a pattern. I think like the passion for sport kind of led like guided you throughout your career. You started from like the sport analyzing, and then the machine that helps prepare LeBron James for the games, and then we can go to at the end the massage to kind of like relax after a game. So it's kind of it's sports kind of themed. So okay, so can you explain what is Tonal? What did you do there, and how was the engineering work there? Go ahead.
Yeah, even when I was at MoCap, we talked sometimes about getting more into sort of consumer, like non-elite level sports. It impacts a lot more people. It's a bigger market. But yes, that's basically what I did when I switched to Tonal. So that company, I mean, they still exist. They're still selling a wonderful product. It's this thing that hangs on the wall, and it helps you do strength training. So it's similar to Peloton. A lot of people know about Peloton, which is like a bike that has a screen and kind of guides you through the workout. Tonal is very similar, except it's primarily for strength training. So there's a screen on it. There's a video of a coach kind of telling you how to do your workout, and then there's no weights. So it's not most weights. Most of the times people who lift are doing strength training get the resistance from gravity and just heavy chunks of metal, right? Here, instead of that, it's an electric motor on the inside that provides the resistance. And there's these two kind of cables that come out, and you can pull on them, and that's how you get the resistance. So because it's an electric motor, it's very easy to change the weight in all kinds of interesting ways. So yeah, I was leading AI and machine learning there.
Okay, so let's pause a little bit. So you used there computer vision and spatiotemporal analysis, right? Because you had to see what the person is doing and to kind of like correct it. So can you talk about that? Like, what was your input, output, and how did you build the model?
Yeah, we had a lot of different sensors, and that made it interesting. So we had camera for sure. We also had, probably the one we used the most was just the sensors built into the device, which were these basically the length of cable that had been pulled out. That was it's a very simple sensor measurement, but it's a lot of information in that one. And then also the handles had IMUs in them. So we could measure rotation and acceleration in the way the person's like wrist and hand were moving, all in real time.
Oh, wow.
So we used that for all kinds of things. The simplest was just counting your reps for you with very, very high accuracy. Very important. No one wants to get cheated out of a rep when they're lifting. It's a terrible feeling. So yeah, that was one of the first things. Other things is we would automatically turn the weight off because it's an electric motor. Again, like if we were sensing that you had completed your set and you were done, the weight could automatically shut off. So that was another area we did. Yeah, there were a lot of things.
Yeah. So also, I guess when building an AI-powered strength, as you said, trainer, how did you handle like the noise to signal ratio in sensor data versus like the cleaner data typical found in like pure software like machine learning?
Yeah, well, first, I'm not sure any data is clean from the start, but I get what you're saying. Like, I think it was probably cleaner, or like kind of web-based data is maybe cleaner than sensor data from the real worlds of like physical world. So there were a couple things. First, I mean, it helped that again, like me and my team, a lot of us came from mechanical engineering or robotics or places where we kind of understood the sensors and where they would work and where they wouldn't. So we had some intuition about when to trust them and when not to. Also had good working relationships with the hardware and the firmware teams. So when we did discover serious problems with the sensor signals, we would tell them and work together with them on correcting the root problem. But yeah, there were still cases like there's still always going to be some noise that you can't fix. So we did a couple of things. Probably the main one was we would kind of delay for a few sensor sort of for I don't know a few samples worth of data before we would complete our processing. So that let us do a bunch of filtering and cleaning before we had to use the data, and we could sort of look into the future a few samples. And that didn't really the sensors were fast enough that the user didn't notice this, but we could do like exponential averaging, so that smoothed it out. It was like a low pass filter.
So you did
Sorry.
like I was going to say, so you did like a pause estimation latencies, like so real-time feedback is critical, right? When you use this type of like product. So how did you balance the trade-off between like this accuracy of like pause estimation models and the inference latency like required for immediate user correction if you do it? Like, it's interesting.
Yeah. I mean, so we were getting our sensor signals, most of them at about 50 or 100 hertz. So fast, a few samples of those a user won't really notice. And more important to be accurate. Like one of the things that we sort of a guiding principle was to not be wrong. So it was okay to sort of abstain. Like you can make a prediction and be wrong, you can make a prediction and be right, or you could just not make a prediction. So we would sometimes, if we weren't confident, simply not make a prediction. So for example, if we were giving a feedback on their form, so if they're like lifting weight, doing a particular exercise, and they're doing it the wrong way, we wanted to tell them that. But if they were doing it in a way we weren't sure was wrong, it would be better to not say anything than to make our best guess. Like if our best guess is only 70% confident, usually it was better not to even say it, because we didn't want them to lose trust in the system.
Interesting.
Yeah.
Okay, so you said the word confident. Are you using machine learning models? What do you mean by that?
Yeah. So we were using machine learning models that output a probability of a particular type of, in this case, good or bad form while they were lifting. So if we looked at that sort of probability of bad form, and if it was above some pretty high threshold, then we would give the recommendation to the user.
Just for users' ability, so we talk about this a lot, that you can't get these probabilities directly from neural networks. We've talked about this. It's a complicated process, but I would never call that a probability, because it's not a true probability, and they have been shown time and time again to be absurdly overconfident. In your case, that shouldn't necessarily. I mean, the worst case scenario here is that you tell them to do a little better.
Yeah.
So that's pretty low risk.
There is a step that you often have to do with models that output a so-called probability, which is the calibration. So you basically check, like, is this output that's supposed to be a probability, does it actually line up? Like if it predicts 90% of the time, if it outputs 9, like 0.9, then you can check for every time it predicts 0.9, of all those cases, 90% of them should be the case it's predicting. If that's not true, then you can sort of add a little extra correction layer after that to fix it. So we didn't do that to be honest, but that is like I've seen people do that to try to correct for these. I'm not sure if that's what you're describing, but there, yeah, that's one sort of way to kind of mitigate that.
I see. And going back to the sort of data you had, so I'm assuming you had both camera inputs and localized force motor sensors, right? Kind of data. So
yes, that's right.
yeah, how did you collect it? Like, because I see from your previous job in the NBA, NFL kind of AI, you have the input from like games. This one, did you test it on all of the engineers who were using the machine? You are all like punched out and ripped thanks to that? How did you do that?
We did test a lot on employees. That's true. To collect our initial data for pretty much every new feature, we did a lot of like it's often called dog fooding. Before we would release anything, we would a lot of the employees had a tonal at home. We had a couple in the office that people could use. It's like a little mini gym sort of, and they got a lot of use. So that was great. It was a really
good perk.
Yeah, it was a good perk and a great test bed. Like a lot of the employees were really passionate. So if there was anything that they thought was not up to like our quality bar, they would definitely tell us. Yeah.
Oh, that's cool. Did you get to keep it if you switch jobs later on, or you have to give it back?
I had to give mine back because I had kind of a special one that it was like some experimental hardware, but a lot of people got to keep theirs even if they left.
Oh, that's cool. That's cool. Because these ones are expensive. The tonal one is super expensive. It's more than thousands of dollars. Yeah.
Well, but I will say the part that makes it really cool actually is the machine learning bit about the tonal product. Like that's kind of the thing that makes it so neat. And so I was really excited when I heard that you worked on that project, Brandt. That's really cool.
Thanks. Yeah, it was a lot of fun.
Is it similar to what I'm assuming Peloton do the same with their product, or no?
Peloton, from the user's perspective, it's a very similar product, but in terms of the technology involved, it's pretty different. So they don't really need as much or the same kinds of AI and machine learning that Tonal did. Tonal was a lot more like an AI machine learning led workout, whereas Peloton, there's like you're only doing one thing, you're just kind of pedaling, right? There's less kind of going on, and there it's a lot more coach focused. Like the coaches are sort of mini celebrities and are most following them. Yeah.
I see. Do you have also AI coaches or no? It's all real coaches.
All real coaches. Yeah. An AI coach would be fun, like to sort of try to make an avatar type AI coach that talks to you. That's probably possible now. Yeah,
it is, absolutely. We have like AI actresses and AI anything. So you could have, because I'm assuming it's a cut in costs, right? You have an AI coach, you give it like many scenarios and they can handle it. Or they can be dangerous and get the people hurt.
Yeah, I was going to say not necessarily because of the lawsuits is what I was going to say.
What immediately springs to my mind is there's a content creator who makes TikToks where he's having he's talking to an LLM or something, and he just says like, "I'm trapped in quicksand and I'm sinking. Can you please save me?" And the LLM is just like, "Oh, haha, nice joke." But I just imagine the AI trainer. You're like, "Okay, that's too hard," and they're like, "Haha, yeah, no, keep working." Like, oh, my arm, my chest hurts. Oh, you're fine. Come on, pick it up.
This is something we had to think about a lot. Is like maybe that doesn't happen in only 1 in 1,000 instances is like that, but that's too many. So because someone can get hurt, and it would destroy trust. So all kinds of the success rate there has to be really high. And the other part though is like people like humans. Like one thing we noticed when we were giving the feedback to a person about their form not being good is they or if they were like the humans almost our users did not like that the computer was telling it a human action. So it didn't like, what do you know, computer? Like you're just, you've never lifted weights. How could you possibly know I'm doing that wrong? So we had to actually adjust the way that we talk to the user from when it was coming from the AI to not sound like a human, like to not sound like a coach, because that was not like authentic. It had to be more mechanical. It was like, make sure you're within 12 to 18 inches or something, because that's something that people believed a computer would like. It was more like what they expected from a computer.
That's funny.
Interesting. Yeah, interesting.
Yeah,
Are
for
you
like
saying
if we
that
said
you were
something like "try harder," like that was not good. If the AI tells you to try harder, there's no like you can't. There's no empathy in there.
Yeah.
This just reminds me of I played a video game on the Wii. I just this whole concept, and the tracking was so bad back in that day that it would just like yell at you, no, no, over and over again as you were trying to do it. Like it's totally the same vibe. But that's really interesting that you had to change the interaction to be less human in order for humans to accept it more. I wonder if there's an analogous problem going on now with chatbots, that they're trying to impersonate humans too much.
Yeah.
I think so. Like if it for example, if a chat bot included like and kind of very human type things, I'm not sure it would not be authentic. I don't know. When I hear like text to speech ones that try to impersonate a human, that include those sort of like little ticks and things, it bugs me. I don't know. Maybe I'm the only one, but
No, you're not. No, you're not, for sure. Okay, so after your work with Tonal, you moved to work with as a leader machine learning researcher at Gretel. So it's building generative AI models to help companies safely use their data. So can you elaborate on that? What is Gretel, and how come you're out of
yeah.
sports right there?
Well, even though I like sports a lot, I'm not only into sports. So Gretel was. We didn't work on any sports data that I remember. We did have all different kinds of data. I was tempted to try to feed it some sports data, but I don't think I ever actually did that.
Okay.
But yeah, so our main business, was for companies to provide us access to their data, and then we would automatically train a deep learning generative model on their data that could then generate more data that was just like the originals, but with minor changes. So the two main reasons companies liked this were they could generate a lot more, so they could train their own discriminative models on the generated data and had better accuracy or sort of better robustness or better. A big case was better, like more balanced classes. So if there was an underrepresented class, they could selectively generate additional data from that class and then sort of remove bias in their final models. And the other big case was privacy. So if their original data had private information in it, we could generate new data that did not have, with guarantees, would not have the private data included in it, but still have all the same sort of patterns. So then they could either share that data with people who had less trust in, or they could train models and be confident that it wouldn't leak any private information.
So can you explain a little bit more here? Like, it's generative AI for data safety. So in your view, can synthetic data ever truly eliminate the risk of like membership inference attacks? Or is there always like a privacy leak? Like how come it make it more, because for me, like this is synthetic, like explain how this is synthetic data kind of help with the privacy. I don't understand.
Yeah, well, maybe first a little detour. So like I think safety in general is always a matter of trade-offs and sort of levels of safety. So like a case I always think about is cars. So are cars safe? Not really, sort of. They're
Yeah.
pretty safe, but like if we lower,
Depend which
imagine
one.
if you lower this,
Depend which one?
what?
Which one? Are we talking electric car, or fully autopilot cars that doesn't exist, or like normal car?
I'm thinking human-driven regular cars,
Okay.
but they're all the same. The analogy applies to any of them. So yeah, imagine if we lower the speed limit. For every 1% we lowered the speed limit, say the number of accidents would decrease 1%, right? Like that's something like that, roughly something like that's probably true. So we could save a lot of lives if we just lowered the speed limit, and yet a lot of people unfortunately do, die from car accidents every year. Like, but we don't really want to lower the speed limit that much. So we make some sort of trade-off here. We could also say, well, all cars must be super, super safe. Like if you ever get into an accident, there should never be any fatalities. But then you'd end up with these like giant expensive cars that have real terrible gas mileage. People can't afford them. So like that's not really, that maybe isn't the right trade-off either. And it's kind of the same, I think, when it comes to this privacy and data. So there's a trade-off. So we could, I will say, like in the most extreme case, so we have a lot of data and you increase the sort of level of safety you want to a really high level, it's practically impossible. Not technically not impossible, but in all practical purposes, like impossible to do a member inference attack. But then the quality of the generated data decreases. Yeah, there's a bit of a trade-off, and there's always the chance of human mistakes too. So even if the tool, so we use primarily differential privacy, and there you get to pick some parameters, which kind of are the trade-off between like sort of accuracy and privacy. Even if you kind of pick the most extreme versions of those, someone could misuse the tool, and by accident, there could be a membership inference attack could happen. So no, you can never. I think you can never completely eliminate the risk. Is the short answer.
Can you give an example of a typical company and what the use of this tool would add to them, so people can understand? Like, so your clients, if you talk about.
Yeah. So maybe it's like an insurance company, and they want to determine. That's not the best example. Trying to think. I don't want to give a real one.
No, I understand that you have NDAs and stuff like this. No, I understand, but like my question was specific because like beyond like standard losses, like how did you define like success for a generative model, like that you're meant for mimic complex enterprise data? I wanted to see it through like an example when you see, oh, this is done successfully and this is not. So,
so maybe there could be a bunch of personal information in the data set. So it could have something like your address, your like
social security,
latitude, longitude,
whatever.
Yeah. That kind of stuff's usually better to completely filter out even before it gets to the models, but that could be in there. People could use the tool like that, and that could be in the training data. And you want to be able to train a model on this data, and then release it to the wild, where anyone can do anything they want to it. And so they could try to like put in, for example, maybe they know a little bit about a person. So they know like their location, they know their age, they know a couple other identifying things. They can input that information and then get basically the output, which corresponds to that individual. So they've kind of tricked the model into releasing information that was private. yeah, I mean, a clearer case is just when it's another human being. So within the same company, you might want to let a bunch of your analysts look at the data, right? And sort of explore the different relationships so they can come up with like manual feature engineering. But you don't want all these different analysts to have access to lots of private data that, maybe accidentally
Like the social security data.
Yes, they accidentally like lose their laptop and then someone else
Yeah.
picks it up and like, oh, look at this CSV. It's got all of these emails and social
Yes.
security numbers and names. So what you do instead is you let the analysts, the machine learning engineers or whoever, look at this synthetic data, which has and should have all of the same relationships in the data. And so they can train models and things and explore and they can mess around with the data as much as they want without a security risk.
You can find the correlation that you're looking for, but with not the real data, but the mimicking data.
Right, and then you could potentially train the final model on the real data, but then it's trained sort of without anyone looking at it, without any human looking at it, or you could train on the synthetic data, or a mix. People do all of those.
Okay, so follow-up question. So if a company uses synthetic data to train like future models, how do we prevent the model collapse or like reinforcement of existing biases present in the original seed data? How do you do that?
Yeah, that's actually one of the biggest uses of synthetic data is exactly this. So once you have this generative model, you can sort of condition it on underrepresented classes or particular kinds of data you want. So like, for example, let's say you're making an image classifier and you don't have enough images in your data set of, say it's classifying a doctor, different professions based on like the way the person looks. You might not have enough examples of like women doctors. And so what you can do is create this model that we would train, that you can specify the outputs you want, basically. Like I want it to be a woman and a doctor, create me an image that has that. And you can create thousands of those and then use those in your training set. So now you have a balanced class. You have just as many female doctors as male doctors. And when you train the classifier model, which takes image and goes to label, it won't have a bias. So but that does require though that when you use the synthetic data model, that you sort of prompt it, you query it on these cases that you're concerned about. So you have to kind of specify what they are. But yeah, this is just one way. I think there's many other ways to sort of handle bias. So you can modify the data afterwards. You can modify the results of the inference afterwards to kind of correct for it. There's many methods. I'm sure I don't know all of them, but yeah.
Okay, and
No, that was a lot of technical stuff. I just want to say it in really plain English for everyone then in chat. That was just like a specific example he was saying where we say that we're just at the mercy of the data, that there are human biases in the data that we're building. So these machine learning models are very biased. We all know this. He was saying that you can fix this bias actually by generating new data that corrects the bias. So we can force it to be not as biased by using these sort of tools, which is kind of cool.
Thank you. That was much clearer.
No, you weren't unclear. You're just a scientist. I'm used to it, but chat's not. So.
Oh, that's great. That's great. Okay, and we'll come back to the data privacy and like safety and ethics afterward. But I want to kind of keep going on your career path. Okay. So after working at Gretel, you kind of like switch to something different, which is, okay, I don't know if I'm saying it's right. Escape? Is it escape?
The A is silent, basically. Just escape.
Oh, so it's it's escape. Yeah, okay. So, which is something very unusual, which is kind of like tonal stuff, but a massage robotics company creating a near human quality automated massages. So I have so many questions about that. So first, can you give me like a quick introduction to this company and what did you do there? And specifically, what are the data that you used for the massage? Because I understand the games, I understand the people like holding stuff, pulling stuff from tonal, but I don't understand the massage. Is it like a feeling data or how does it work? So tell me.
There was a lot of data, to, a lot more than we had at Tonal even.
Oh my God.
So
Okay. More.
I guess, yeah, first, the way that this robot works is it's a big massage table. They're in massage studios throughout the country now. I forget exactly how many they have out there, but a lot. So you can get one today if you wanted to go get a massage from a robot. I've done it many times. Yeah, you lay on a massage table, then there's 4 cameras mounted above, kind of looking down on you. And then there's 2 robot arms that kind of come around from the sides and can push on you from like your shoulders and neck all the way down to through your legs. And there's a little screen, like a tablet touch screen, that you can use to control settings and things during the massage.
This sounds very scary. It can strangle your hands on top of you. So explain to me how it works and how you are getting the data.
Yeah, well, okay, I guess in terms of how we get the data, there's the cameras are the main one of the main ways. So we get there are depth sensing cameras. So these measure basically the 3D the depth of the person and their time of flight, so they can measure pretty accurately how far away every point in their field of view is from the camera, and from that we can figure out sort of the me and my team figured out the sort of the shape of the human body, and then we'd fit a model to that. So this is not quite the same as like what you think of like a machine learning model, but it's more like a like parameterization, I guess you could say, of the human body. So once we had that, and we found a model of the human body that closely fit those points, then from that model we could sort of infer where all the different underlying structures of the person were, which is what we really needed to know. So we knew where the bones were, the muscles, different kinds of muscles and all. And then from that, we could map out where the robot arm should push, like down to like less than a centimeter. Like we had to be pretty accurate to make sure we were pushing on the right spots.
But you have to kind of feedback loop it with the client feeling. Like you can say if it's too deep, to like what kind of like say if you're doing it right or no.
Yeah, we did have some feedback. So we knew where the surface of their body was, and then we knew kind of how far we had deformed it by pushing on them. And so we had some feedback there to make sure we didn't push too far, too little. And that was the main form. Yeah.
Yeah, I was going to say, did you utilize like reinforcement learning for these like control policies on escape? Like if so, like how did you define the reward function, like to balance efficiency like with user comfort?
Yeah, we did not use reinforcement learning, although I do think that is a good thing for them to do in the future as they collect more and more data from real users. We used well, for the feedback part, it was really just sort of classical like optimal control with some heuristics built in, and we tested it a lot on people to make sure we had all the parameters right. But there was not like, there wasn't reinforcement learning, at least not yet.
Yeah, but the humans are like have different high variances of like variance, like body shape and pain tolerance even. Like a massage hard on deep tissue on someone is like not that hard on someone. So how did you design this system to adapt to like specific user physiology in real time? Like how like can you adapt like when you use it? I'm curious. Like is it in real time adaptation or because like in the masseuse you can tell them like hard here, go left, go right, stuff like this. So how do you do that with the robot?
Yeah, So this was, first off, it was an early stage startup. So there were a lot of things that we wanted to do and we had on the roadmap, but we just had to prioritize getting certain things done and releasing the product first. But we did have some of
releasing the product without all these things. Like, aren't you like,
well,
if it's not ready, how come you release the product?
I think we had enough that it was ready. It just couldn't, there's always more. So I think what we did have was the most important thing. I mean, two most important things were the user could control the amount of force throughout the massage. There was like a dial they could move, and immediately it would react and sort of just proportionally scale up or down the force. So that was they could pick how hard they wanted the massage to be. And they could do that, throughout the whole massage. That was always available to them. And then the other thing was a safety mechanism where they could just push a physical button, and that would immediately stop the massage. So if anything was like too bad, you push this button, the robot arms would immediately retract, and the person could restart the massage if they wanted, or just
switch kind of. Okay.
But what you're talking about sort of moving it around a little bit, saying like do more of this, less of that. We had some of that in the beginning of the massage. You could say like I want these parts of my body, not these other parts. But during the massage, I'm not sure. They might have this feature by now, but I don't think when I was there they had the ability for you to like say a little bit left, a little bit right. But they were that was in the works. Yeah.
Okay. Yeah. So, and again, like Tono, everybody had a massage robot in your team to kind of test it.
Oh, I wish. These were a bit large to fit into like a typical house. So they were also pretty expensive. So the business model was to lease them to massage studios. But yeah, we didn't have enough. They were too expensive to have every employee have one at home. But we all had access to it in the office.
So by studying and trying to work, you get a massage in your office. That's cool. That's a good perk.
Yeah, it was. Yeah.
Okay. So I think you touched a little bit about that, but I kind of like want to go back about the biases in physical AI, because tonal or these massage things, like in healthcare and wellness robotics, like training data often is biases towards certain body types all the time. So we see it in healthcare in general, with humans have biases, like Black doctors versus regular doctors for Black patient and things like that. We hear it all the time, that like we need to have diverse healthcare workers to treat diverse population. And I'm curious to see if like, how do you audit a physical AI system to ensure it performs safely across diverse demographic? And I'm not talking about specific this physical thing, but it's part of like robot, like home speakers and things like that also are biased toward like certain accents and not others. So how do you work on towards this diversification? I don't know how you say it, but diversity.
Yeah. A couple. There's lots of components to helping with that. So one is just splitting the data along those dimensions. So with robotics, with the massage robot in particular, very small people, very large people, like very different body shapes. We would maybe not perform as well, especially sort of on the edges of the distribution where we had less of that data. So we had to look carefully at the few cases we did have. And a lot of this was also before we had launched. So we tried to intentionally like get people to come in and test it who are on the edges of our distribution, so we could have a better idea and improve the system for those people. We also, though, at some point had to say like there are certain there's a sort of a cutoff where beyond a certain like extreme sort of on the part of the distribution of body shape, we can't do that well yet. And so we would not have these, like we would try to screen these people out before they purchased it, before they scheduled it, because we knew it wouldn't be a good experience. And in the meantime, like try to improve it so that they could come at another time. But That's just, it was sort of a practicality, an unfortunate one, but that's there's a lot of different kinds of body shapes out there that were hard to support all at once. Um, what was the other thing I was going to say? Another thing to look at is when we were releasing new models, to look at the accuracy change by user. So rather, like a lot of times you look at like the average accuracy increase across all users, which is useful, and like the loss is often usually across all of your examples, and but not at an individual user level. What I like to do is look at the accuracy change for each individual user and look at that distribution of accuracy change, if that makes sense. So if you see certain users are getting really negatively impacted, but the average is like, most users get a slight bump, but then a few small set of users get a large decrease, that's usually a problem. And then you got to figure out like, what is it about these users that's sort of the pattern that's causing that, and try to fix it. But before a release, I like to look at that.
Okay.
So this kind of brings up a question that I have to ask you. This is moving much more from the grilling details to like in general. So you worked at all these startups, right? There's all this pressure, particularly in machine learning, to like push, get the models out, get the models out. I just want you to talk about your experience in the process of doing data science at a non-pro, or I'm sorry, at a startup like this.
Yeah, so I echoed that because I prepared a question exactly about that. I'll add more. So you've led like machine learning research teams throughout your career. How do you manage the tension between like researchers who want to like publish and perfect like novel architectures, and product managers who need a good enough model shipped like yesterday? And in the current landscape of massive like API, OpenAI, Anthropic, blah, 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 how do you decide when your team should fine tune a foundation model versus like training a smaller and specialized model for like scratch? So talk about this, like kind of what she was saying, like the pressure versus like doing the thing right versus like the pressure of like getting something out, especially in the industry, because we know it through the research and academia, but through the industry.
Yeah. I mean, at small stage startups, the focus is very much on, you're fighting for your existence. So it's a lot of focus on get something released, and maybe it's not the best model that you could do, and it might not be publication worthy, but you need something that works, and get it out. And then once you've sort of the company's existence is at least somewhat safe, then you can do more groundbreaking, more novel type things that maybe would be publication worthy, but they tend to take a lot of time and resources to do those. I mean, such how research is. It's a lot of trial and failure, and like trying again, trying new things, and that's how it has to be. But that takes a lot of time, and there needs to be a good business reason for doing it. A lot of times you don't really need a groundbreaking model to make a great product. Sometimes you do. Like sometimes there are parts of a product that you really need to get that last little bit of accuracy, and that really does make a difference in the user experience. But the focus is much more on sort of productionizing things at early stage companies.
Yeah. Kind of like in the same well. So how do you assess the risk of an open source model being used like for harmful purposes, for example, like bioweapon synthesis or something like this, versus the benefit of open research, if you have any experience with open source and open research? And where do you draw the line?
I mean, I'd love to open source things when possible. I think a lot of people are reluctant to, because they think it's gonna, a competitor is going to overtake them in some ways. But there's so much that makes a company succeed that I don't think that open sourcing really makes a difference that much. Like I just imagine like at Escape, for example, I was sort of in jest, but I was like, we don't even need patents. Like this is so hard. No one, even if we gave people the blueprints, like they'd have a really hard time making this work. So I think open sourcing things in general is great, and it attracts new talent, gets people on the team recognized, which is all great. And often like it can sort of spark conversations that can improve the product even more. So I'm usually in favor of publishing things, at least in like blog posts, if not like conference papers.
Okay. And in general, like, are the startups like encouraging for the publication and for the kind of like opening up to the research, or really more secretive?
I think most startups are pretty secretive. I think that they think that, and somewhat correctly, like that what they're working on is really important, and their competitors might be able to catch them if they release things. So I think for the most part, startups tend not to publish. It depends on the startup, of course, but I think most of them don't. Some use it as a strategy. They open source things and create even a free version of their product. Actually, at Grotto, that's how they started. Was with an open source version.
Okay.
And then later on create a paid version which has like additional functionality.
Okay. Amanda, do we have some questions from the chat? I don't have access, so.
Chat has been a little broken, so I think it's working now, at least on the Twitch side. So if you have any questions, please put them in the chat. I actually have another question. So your background and your PhD was obviously not necessarily in data science. Can you talk about being a PhD out in the world and what it's like to move around into new fields?
Yeah, I really like it. I like being able to sort of use the same or at least similar sort of methods in lots of different kinds of problems, lots of different kinds of companies. It's exciting. There's a good number of PhDs who followed a similar track to me into machine learning and data science. So yeah, it's not uncommon for people to do this. Yeah, it's great.
Do you have any tips?
I think a lot of machine learning is actually software engineering. It's cleaning data, being able to work with data efficiently, write good code. So I guess the two things I'd say are that there's some really good Coursera classes. Andrew Ng's are amazing. That's what I learned from. He's still putting them out. They're great. And then, sorry?
I was going to say, I know it. I know the classes. Yeah, very cool.
Yeah. And then just get good at sort of software engineering. The best way to do that is just to start to try to do things. Especially the larger the project gets, the better your practices have to get. It's easy to write a couple 100-line script, but to write 10,000 lines in a complicated code base, you have to start thinking about the design more. So trying to get involved in. Yeah.
I was going to say, speaking about that, what's your take about like the new direction that like, Claude and ChatGPT are doing vibe coding or coding as a whole? So is it still worth it to be a software engineer or to study for a software engineer if you have like an unlimited powerful tool that can do that for you?
I think it's hard. I think so, but it's a wild world we're going into. It's really hard to predict what skills are going to be needed in the future. AI is changing so fast. I guess certainly the AI coding tools are a huge boost in productivity, especially when used the right way. If used the wrong way, they create a lot of technical debt and can be a problem. But used the right way, they are great. To use them the right way, though, I think you do need to understand what you're doing and like what the code is doing, and kind of guide it a bit. At least right now, guide it a bit on like being well organized and following good principles, and sometimes correcting it. In 5 years from now, like hard to say if that will still, maybe it'll be so good it doesn't even need as much correction. But I think the market for, it's not like there's a fixed size of amount of like code that needs to be written every year. And now half of it's going to be written by AI. Like if AI can speed us up, we'll just write more code. Like there's a whole lot more, like we can go faster, write more code, create more businesses and services and all. So that's what I hope at least, is that we can go faster, and there's so much sort of pent up demand for more kinds of software that software engineers will still be in need.
You're from the half full cup kind of optimistic person about that.
I'm really uncertain. Is more, I just don't know. I'm trying to be positive, but it could go bad too. Yep.
Yeah, no, for sure. And so here's another question. So what is the one non-technical trait that you like kind of think would be valuable for people to look for when you are hiring or when you apply for a job? Because I'm sure, like,
Sorry.
yeah, you had like interviews, you interviewed people for different roles as a leader in machine learning in different startups that you worked for. Like, what are you looking for? Because if you tell me a computer scientist who can write code, there's tons of them. So
Yeah.
what would be the difference? What would make the difference?
What I look for when I interview people is general curiosity. Like they like to solve problems, they like to learn new things. It's pretty rare that a person has all the skills they're going to need already. So I want someone who likes learning. That's sometimes hard to judge, but you can usually get at it. Another thing I look for is sort of mastery of basics. So I don't like to ask really tricky coding questions or like brain teaser type things, because I don't know, in an interview setting, you're kind of nervous and it's easy to get kind of stuck, and then you like get in this loop of like, oh, I'm not figuring it out fast enough, and then like they kind of go off the rails. So I think it's better like ask simple things and make sure that they truly understand them. That also usually means they don't have to study as much, which is good. Like if an interview can be studied for a lot, that's I think kind of a sign that the interview's not really testing the right things. So yeah, I like to ask basic things and make sure they have a really deep understanding of them.
And you're not against someone who's interviewing and using vibe coding for that, or are you?
I am against that. Yeah. I mean, if I was asking to do some sort of project where in at the companies that would be expected to use AI tools for it, then maybe that would be okay. But like the kind of questions I ask are like 5 lines of code. So
yeah, it's more thinking and less doing. But you use vibe coding for your everyday work, right?
yeah, I still review it pretty carefully, but I use AI tools to help me with code. It's so fast. Like if I'm trying to learn something new, then I might make myself write it by hand the first time. But if it's something I already kind of know how to do it, it just kind of, it seems like a waste of time to write it myself first. Like better to have it write the first draft and then I just kind of fix it up.
Yeah, so this is a perfect segue for what Amanda is doing about the rating system and how do we rate the coding that we're producing. So Amanda, would you like to talk more about that to Brandt?
Sure. I'm not sure if Aman has told you about this at all, or if you're watching the stream at all, you might see a little 1 under Bob. Basically, what that is, it's we call it the real rating, which is the reported engagement with AI level, which people are saying like, yeah, use AI or no, don't use AI. And we think that that's not enough information that people need to be providing and talking about this on more of a graduated scale, if you will. And so the general idea is just like the first couple levels are like automation type things and then brainstorming, and then you get into like how much the AI is actually impacting the product. And the point is, this is kind of based on like there's a similar scale for like autonomous vehicles on how autonomous the car is itself. And so the idea would be like you can use it to like set policies. You could at like at education level, at a company level, you can define how people should or shouldn't be using AI, etc. And so the I guess we'd love to get your opinion on something like this, and if something like this might be useful to you.
Uh, sorry, how can I see this?
So on the on the Discord, you can see the one with you and Bob in it, if you're in it.
I don't think I am.
It's just a one. It's not that exciting to look
Yeah,
at, but it's
the
just the
graphic
rating.
itself. Imagine like how movies are rated, you know, PG, PG-13. How video games might be rated like E for everyone, T for teen. It's a thing
Okay.
like that where on your live stream, like I'm doing it, or on your product, or on your webpage, or like Mandy was saying,
Your code,
within your
yeah.
company for standards, or if you're a teacher professor, you could say this assignment can only you can use a tool that rises to a level 1 or level 2,
I
but
see.
no fully AI generated content for this assignment. It's a system like that. The actual graphic is basically just a number, but
Yeah, it's from 0 to 5. And like 0 being no AI, level 1 means automation, level 2 brainstorming, level 3 moderate AI, level 4 major AI, and level 5 is like full AI in their use.
Yeah, I see. I see. Yeah, I like the idea a lot. I'm trying to think of like specific examples where I would want to use this. I mean, so I guess first, this is entirely self-reported. Is that right? Or is there a way to like automatically check?
yeah, so it's
Yeah,
complicated,
that's
right? Every application is it's very subjective what level it might rise to potentially depending on the tools of the specific medium.
But I
Or
sense that you have
but
an idea, Brandt, to make it automated, reported with some LLMs, right?
Well, I would love to, but I know there are companies that try to do that to detect AI, whether it's been created by AI or not. Although I think those are mostly binary, not this 0 to 5 reading. But it's a really hard task and like a constantly moving target. So self-reporting, like that might be, at least in some cases, that might be a better way to go about it.
Yeah, especially
yeah, we
in
thought so for the
education.
same reason.
Yeah,
Go ahead,
especially
Aman.
for education. I was going to say, I think I read recently, like there was like a first student who got, I think his PhD rejected or thesis rejected because of the use of AI. Because he wrote like the thesis report or something, and then the professor went and typed the same prompt that he figured out he used and got exactly the same, like, points and subsections and things like that. So yeah, I guess it is hard because like yeah, in education it's true, but like can you imagine expanding this tool to images and things like that would be like super super hard. But
Yeah, I mean, I think like at least within a company. So say someone commits some code that they want merged in. Um, they could report. I've seen people do this in their comments, be like, "Oh, this was AI generated," or not. But this kind of scale might be better, and I think that would help the reviewers who are looking at the code decide like how closely do I need to look at this. Um, so yeah, I think it could be useful there at least. There's probably other cases. I'm just trying to imagine others. Um,
Our favorite case that we like to tell people about is we have this dream that social media will be you'll be able to filter your feed by these levels. So you won't be
yeah.
scrolling and then just get Bigfoot out of nowhere, that you'll be able to choose your own adventure on that front.
I
Um,
thought Bigfoot was level 0. I don't know.
I mean, whatever you choose to believe.
yeah, and it's just like we're not here to judge, we're here to give the choice. You know what I mean? Like it's like, it's like giving the information, like when you buy any product for food, you have all the information about like the trans fat, the protein, the whatever, and then you get to choose what you eat. I'm not like preventing you from choosing this product or the other, but I'm giving you the information that you need to make your own choice. Whereas like I feel in the real life, you don't know where is AI and where is not, and it just feeds it into you, and you have no idea what's in your watching, because I see it as like a food reference. You don't know what you're watching, you don't know what you're eating. All these things that
Yeah.
are included into what you have. Yeah.
It's tough just because there might be bad incentives for people to lie. So like there needs to either be trust or uh, there's no real incentive for someone to lie about it. So like when you're working at a company like the code review case, I like that one because there's not much real reason to lie there. Assuming you've got a decent work culture. But there are other places where you might want to, like when you're submitting an assignment for a class, you might not want to admit that you used AI even if you did. So those cases, like I mean, it seems like it would be harder to use this kind of thing. Maybe there's a way to get people to do it and be somewhat honest, but when there's sort of an adversarial component to it, it makes it harder.
I'm totally with you, but where it's at right now, most of the guidance is either don't use AI or yes, you can use AI, and then it like the all hats are off and people don't
Yeah.
use it in proper ways to make it appropriate
Yeah.
regardless. So yes, there will be absolutely bad actors. In certain scenarios, I can imagine there being consequences. The education scenario is a little bit more challenging because the proof aspect of changing their grade is a little bit harder. In social media, like there's all these things already about like copyright strikes and things like this that exist when you're like against terms of service. So these are just like things that just like auto click, and then you have to like go through systems of like
Mhm.
uh, saying that that's not true. And anyway, so these sort of things already exist in some realms, but I can see what you're saying about the educational component, but we have to tell them something, right?
Yeah. Yeah.
Yeah,
Yeah.
and yeah, for sure. And the I saw on the chat that someone was saying like vibe coding is a 4 or 5. It depends. Like what you just said was, I found it super important. Like you just said like if there's something that you know how to code, like a regression or something, and you just don't want to waste time doing it by hand. But it's not like, for me, I don't see it as like a total reliance on AI. You know the thing, you can write it, you just generate it quickly with AI. It doesn't mean that like you don't, like you rely blindly on it. You know the function, you give it like a specific portion of whatever you're doing to code. I don't see it as like 100% relying on AI.
I
So
think there's a difference between vibe coding and what you're describing, which is coding integrated with AI. I think when people hear vibe coding, they generally think, give me an app that does this.
yeah.
Yeah. Yeah, I think
But it's
vibe
not.
coding extends pretty far. I mean, that's definitely a thing that exists. There are tools, I mean, tools in air quotes, but like the Rabbit R1 is a product that's it's just a little, I have it sitting right here. It's just a little orange box that's powered by like an LLM, and you can there's a tool on this where you can start a conversation with an agentic AI and just be like, give me an app that checks the weather and then gives me a picture that represents what the weather, whatever. You could set your own arbitrary thing. And it's used by people who are more like me, where I have no formal experience coding anything. And I'm sure if I worked on it, I could figure it out. And I'm smart enough to probably code at some level. But, it's used by people with no technical knowledge, who are not reviewing the code for quality, accuracy, whether it's doing what it says it's doing or whatever. Like they're vibe coding from start to finish to accomplish things. And I have no concept of how widespread the usage is on that, but if you believe the internet, if you believe discussions that go on, it's pretty widely used by people with maybe no serious risk to other individuals, but also no technical understanding, very different from what Brandt was talking about.
Okay,
And
so
what
how
coders
do
and
you,
professionals might do.
Yeah, but like, how is it different from like WordPress for websites or Canva or stuff like this, where it's a tool, you just push buttons and then it will give you a website and things like that? For
Well,
me, it's
depending on how reliant you are on, those can all rise to levels that are, up to five. There's nothing that precludes it, given it's not an LLM or it's not a generative picture model that you went to. Oh, I can't even think of the ones off the top of my head, like Sora or something. Um, uh, it can still rise to the five,
yeah.
even if it's a specialized tool. We just carve out the specialized tools and automation stuff in the
Mhm.
ones just because they're not generative. So for example, our stream right now, everyone, is a one. And I do want to note this because last week we had a zero mistakenly, and we admit that we made a mistake of that. Bob's tool actually that cuts out his face and makes a green screen. He doesn't actually have a green screen behind him, but it is an AI tool that he is using to cut that out. Now, is that a high risk application of AI?
No.
Absolutely not. That's why it's a one. There's no generation of any image. He's not generating his voice, his likeness, anything. So that's why it's a one.
Yeah, sure.
Makes
Maybe that
sense.
was a side tangent, but
But yeah, vibe coding, I agree. I think that usually means you're basically just accepting everything the AI says, not reviewing it, and
Yes.
often done by people who probably wouldn't know how to code anyway. I guess that's not, yeah, that tends to be what I think of vibe coding, which I have done once in a while, just like going really fast on something that I don't care much about. Like, yeah, whatever, I'll accept it all. I'll deal with it later if it doesn't work. um, but
Mhm.
not that often. Yeah.
Okay. So now that we talked about all of your past career positions, so I heard that you are kind of like thinking about joining new AI startups or thinking about new startup ideas. And what I like about it is like you were thinking about something around preventing AI from being used in an unethical or harmful ways. So can you talk more about like this and what you have in mind? Maybe we can find you something.
Yeah. So I've the past year or so I've been working on my own startup ideas. I've gone through a bunch of them, mostly AI related.
Mhm.
Um, One I've been working on, I do care a lot about preventing like unethical use of AI, and so it's an area that motivates me a lot, and one that like I've
For
been trying to come up
example, give
with.
example.
Yeah, well, one is cheating in interviews. So there's a very common thing happening now where where people are using they'll have like some kind of AI running in the background that listens to the question from the interviewer
Yes.
on like a Zoom call, and then it will transcribe it and answer it, and then the interviewee will read back the answer as if it's their own.
Yes, we
Um,
had a stream about that. I want to give a shout out to a
okay,
stream with Simon LeBlanc,
yeah.
who explained exactly that on one of his interviewer position. Yeah, yeah, yeah.
Yeah. So my thinking on how to was to prevent this somehow. There's lots of ways you could prevent it. Like you could just have people come to the office, but that's it's expensive, and people have to travel a lot, and uh, so it would be nice if you didn't have to do that. If you could continue doing regular like video interviews. And my idea, one way to stop this would be to make it so that AI cannot transcribe the audio, um, by adding just a little bit of distortion in just the right way. So this is one case to use it would be interviews. There might be other cases that I haven't thought of, but interviews was a clear first use case. And yeah, so I've been working on that. It's tough
Oh,
because
wait. So this one
yeah,
is like you're adding like the sign stop when you add some noise in the picture, or like the panda
yes.
who looks could be like a cow or whatever. If you add little thing that you don't see it by eyes, but like in the interesting. So how do you do it in? You can do it in noise.
Yeah, so yeah, it's been it's called adversarial
Yeah,
machine learning
adversarial.
often, and
Yeah.
It's been used a lot in images. I think it's easier to demonstrate in images, so that's been and also a lot of people have been worried about how it might be used against autonomous vehicles. So there's been a good bit of research in it there. But yeah, there's lots of use cases. Preventing deepfakes is another. But yeah, this particular case is to prevent transcription. And the way it works is there's lots of ways to do this. But the way I've been exploring the most is doing input optimization. So given the input audio, you want to basically do gradient descent to modify the input as little as possible, such that you get a different output, where the output is the transcription. And how you measure the amount of change in the input is you could do it a simple way, which is just sort of the simple norm of how much you've changed the audio. But the way humans perceive audio is not quite the same. So I've been trying to use ways that kind of humans won't perceive the change, but AI will. So the part of the loss function
That's
is
a music in the background or something.
right. It's surprising how there's so many good so many parts of the system now where like in Zoom that and in the speech to text models that remove things like that. So you would think like, oh, just add like an air conditioner noise or a fan in the background or some music. Yeah. That does not work very well at all. There's denoisers are really, really good. So like I'm sure there's one running on this call right now. There could be some noise in the background. It gets filtered out pretty well by AI. That happens in most like video software by default. We don't even a lot of people don't even think, don't even realize it's happening, but it is. And the models themselves have been trained. These speech to text models have been trained on pretty noisy data, so they're quite good at handling noisy data. So it needs to be like pretty targeted, like the kind of distortion.
I see. Okay, what else?
I've got another idea I'm just kind of playing around with related to this. This is not an adversarial idea but it's a synthetic data idea, kind of a different approach to synthetic data than I've seen done much before. Yeah.
I see. But it's the same goal as the synthetic that you talked about.
Yeah, pretty similar. Yeah.
Okay. Mandy, do you have other questions?
I don't. We should let Bob ask questions, though.
Yes.
Well,
Bob.
the transcription thing I think is really interesting. This is in creative circles, sort of imperceptible watermarks on images and this sort of adversarial stuff is, I think, a popular idea and among the creatives.
What is watermarking for people?
Well, it's the same concept that Brandt is talking about, but basically on an artist who's posting something online or whatever, posting something they've made, can use a tool that in a similar sort of way to what Brandt is discussing adds a layer of noise or some sort of thing that's basically imperceptible to the human eye that makes the image not understandable. You mentioned it too, like the noise that makes an image recognition program think that a cow is a bus or things like this. These sort of tools are really popular, but I'm not an expert, but I hadn't heard of an audio application of this. And the way you're talking about it sounds like it would potentially be, I mean, in your theory, your startup idea, it would be like a live tool. I'm assuming you played around with this to see what sort of results you could get, at least to some extent. Could you hear it? Or like if a music artist wanted to post something and wanted to do something like this to create like an audio watermark type of thing to make AI, make it so AIs couldn't steal their music. Well, use their music in whatever application they might. Is it good enough for that, or is it kind of a thing you can kind of hear? It's really only for certain applications. What sort of results have you seen?
Yeah. So far, what I'm still kind of tinkering with it, but so far it works. You can definitely hear it when it's recorded audio, and I have sort of more time to process it it can be more targeted, and then you can tell a little bit, like you can hear a little bit of distortion, but it's definitely understandable to a human. So that's, yeah, when it's recorded, it's pretty good. When it's live, just because of like the restrictions of doing it very quickly, I've had to use different methods and they aren't as effective. So then it's harder to understand. You kind of have to listen to it 2 or 3 times before you get it. So that, you know, that's not good enough for this application of an interview. It's possible to make it better. There has been some other research people have done on it, but most of the research, like in papers, is not as practical. Like they haven't considered all the cases you have to deal with in the real world, and so they've had results where you can hear it, but it's that wouldn't be good enough for this like anti-cheating tool.
I do have a question though about the methodology, right? So usually when you're training those adversarial models, you know the neural network architecture of the model that's been trained that you're trying to trick. Do you consider this a major hurdle that the models are constantly moving and adapting, or are you not concerned with that idea?
Well, it's definitely a concern. Yeah, it's a good point. The way I've been doing the training is I don't know. Not only are the models changing over time, but I don't know what the cheater is using.
Right.
So I've made a system that works on all of them simultaneously, and that makes it a good bit more distorted. If it was just one, if I knew what they were using, you really can't hear it almost at all. But when it has to work across multiple denoisers, you don't know what the denoiser is either, and multiple speech to text models. You also don't know like the compression being used. Like there's a lot of variables. So I basically do a joint optimization on all of them simultaneously. Yeah.
Got it. Cool.
Yeah, that's great. But I'm thinking like this could be used for interviews and stuff, but it can be used also for like, you know, artists or other who like have like kind of a watermarking or signature or something that like do not
Well, I
want.
think Bob perked up because
Yeah.
streamers would be really
Oh
interested in
yeah.
this, right? Because people are going to start making deep fakes of them, right? Like there's only a matter of time, right? The clock is ticking. And so if they could disguise their likeness just so that it couldn't be an unauthorized AI replication, I think that they would all be really interested in that.
So you find yourself the market that you have to target.
Yeah, well, it is
Preventing
a big.
deepfakes.
The deepfake thing is a concern too, a concern as well. But even
Yeah.
just as simple as the Google's VO video model. So VO3 came out, and it's capable of making a lot of very realistic stuff. It's a Google product, and it's conspicuously good at generating the kind of videos that you might find on YouTube. There is no proof of any claim that Google is using content or violating any terms of service whatsoever, but it seems like the VO model was trained pretty heavily on things that look like YouTube videos, because you can tell it, make this kind of YouTube video, and it will produce, it knows exactly what you're talking about. There's a lot of concern across video creators of all sorts, of streamers and YouTubers, of like, we have a lot of content out there, and it's not necessarily even that any of it might get used, but just that it's really hard to control rights on stuff that you're posting online. And before the considerations of AI, but a tool like this potentially would be really good, because live content is tough, and the live interview is a tough problem. But on stuff that you're editing and processing for YouTube or other sites where you're posting the video, you got to take as much time as you might want to make your final product, and then use the tool that you're describing and let it process and let it come up with the least intrusive, sort of way to still protect whatever your content is, or even just parts of your content. I'm assuming, if you're editing something with multiple layers of audio, you could apply it to specific sections, or, in a world where this tool exists. It's just fascinating. I think there is a really big market for that among video creation types, but also if you get in anything above anything where there's a big company backing it, there's a lot of lawyers and copyright machinery that exists that they use pretty aggressively to defend their rights. So the big money part of that market might not be as interested as the independent creators, but it's just interesting. I hadn't really heard of that, but if you could get the live tool working, I think that would be huge in a lot of applications. And in my industry, I think it would be really huge.
Are you thinking specifically anti-deepfake or anti-transcription or something else?
Anti-deepfake, but also sort of, I guess, preventing, I don't know, preventing AI,
Taking
I don't
the
know how to
voice.
describe it, perceiving the content, because there are a lot of tools that scrub the internet, scrub social media, and will give, you can go and say, give me an idea for a social media post about this topic or that is like this post or whatever, and the tools will literally go pull examples, or they're trained on
Preventing
specific
his
examples.
content. You want to protect your content.
Yeah, you're
basically.
you're protecting the idea that is your content, or maybe it's the unique thing that you've made, if it's like a piece of music, or if it's, an acting performance. Like, there's a lot of different ways that content posted online, visual and audio content, would, I think, benefit from that, because small creators don't have a lot of weaponry to, even if, if you're a small creator and large company, McDonald's, Coca-Cola, some large company is like, ooh, we want that, and they take it and they use it in a commercial. There's not a lot that you can do against the tens of millions of dollars of legal department that a company like that might have. But tools of this nature, just to make it more difficult to steal in those sorts of ways, would be really interesting.
Yeah, absolutely. Yeah, should think about it more. Try to find another application there. Yeah.
Yeah, for sure. What else? Any other question, Mandy? Or I can go on?
I don't know if we're about at the end here. Maybe we should ask one more fun question.
Okay.
You have a fun question, Bob? Oh, sorry, Aman.
Yeah,
Go.
no, I don't have a fun question, but more a practical, like, I guess with nowadays, like, job market. And you're kind of like looking in the job market, but I just want to have your sense of, like, how is it going? Why we hear from the media that, like, it's the worst job market ever, specifically to, like, computer scientists, and we hear a lot of layoffs and things like that. So what's your take on that? Are we kind of like, is it a doom kind of market? And I ask this to any AI person here. Is AI in a bubble? And when is it going to burst so I can sell all my stocks?
Yeah, I am looking for new jobs now at the same time as like working on startup ideas. And in my experience so far, it's been maybe a little harder than in the past, but there's still a lot of job postings. I've heard rumors that some of them aren't real. I don't know if that's true, but there's that rumors out there. I think it probably has hit more junior, like entry level positions the hardest for software engineering, at least, and machine learning, because a lot of that work is easier at this point. It's easier to just ask AI to do it. You're going to have to, like, someone more senior is going to have to review it anyway. And so having AI do it is cheaper, even if it's not as good. Like, it's just so much faster and cheaper. So I feel bad for the people who are just starting their careers now. It's probably pretty tough. And I think it's probably true, really, anything that is digitized. If your work output goes into a computer, especially if it's text, but even video, like, it's probably going to get harder and harder. Like, more and more of the work can be done by AI. And so if there's not sort of extra demand out there for the work, then there'll probably be a reduction in jobs.
Yeah, but are we hitting a wall? Because, like, these senior software engineers and ML people are not going to stay forever. How do we replace them if there is no junior and they're cutting on junior?
The more cynical view is, do we need to? Like, if AI is so good, maybe we don't need a whole lot of new people in the fields. I kind of hope that's not the case, but that might be the direction we're headed. Maybe we only need enough to kind of oversee it and guide it, and maybe that's half or 25% of the current sort of size of the workforce in AI and software.
Yeah,
I'm not sure.
and would
Or
you?
a more positive spin on that is we could have 4 times the amount of
Yes,
companies
of
and
output.
jobs.
Yeah,
Yeah, output. There
yeah.
you go.
That's good. Okay, okay. And are we in a bubble, AI bubble? Do you believe in that?
I think the companies are overvalued today based on what they, their revenue. Clearly, there's no debate about that. Like, so the question is, will they grow fast enough to kind of make up for the overvaluation now? I I don't. I think it's probably somewhere in the middle, I guess. Maybe that's a cop out a bit of an answer, but I think their revenues will catch up a lot to the high valuations. I do think AI it's moving so fast. Um, but uh, I also think that the valuations are just so high. I don't think they can fully catch up. Some of them also, I think there's a lot of competition. So like on the whole, AI, I think is going to continue to improve very quickly. There's going to be a lot of successful companies in it, but exactly which ones is hard to say. I think a lot of the leading ones now may actually fail. Um,
I see.
so some of them, like you just broadly, yeah, AI is going to continue to be a massive area, but like, is any specific startup going to succeed? Like the chances are probably lower. I think there will be some that fail. Like, do we really need? I mean, it seems like the kind of market where how many like foundational chatbot companies are out there? I think probably the market could have fewer. Um,
Yeah. So it's like a .com kind of burst, because like after the .com, like not all the companies that are like tech companies went out, but some of them, and it's kind of like a natural cleaning of like the useless one versus the good one. Okay. Okay.
So
So
it can be any sort, but pick whatever your preferred media is: movies, TV, books, video games, whatever. Do you have like a favorite depiction of AI, or like a futurist sort of thing where it's like the
yeah,
AI in 100 years? Do you have a favorite one of those?
one. I'm not sure if this has answered your question, but one analogy I like to use is like art versus posters, and that being applied to video. So, like in the past, if you wanted something to hang on the wall, it would be some sort of artwork. And then we had like digital printing, and we could make these posters, and they were cheap, and there was not much human element behind it. You didn't know who created the poster. You cared about the content of it, but you didn't know who created it. But with art, you care about the artist. I feel like movies like that are currently that way. Like you care about the actors and the director and all the people who made it. But in the future, maybe we'll have AI movies that are entirely generated. I guess there are people who are kind of prompting it, but the people and it's very much less a human thing. And I think people, if those kind of these AI generated movies are much cheaper than the human created ones, I think a lot of people, they might still prefer the human ones, but do they prefer them enough to pay 10, 100 times the price? Sometimes yes, a lot of times probably not. So I think like, there will still be a market for human made movies, but it might become like the high end part of the market only.
You answered a very serious question, but the question Bob was asking was like, do you like Star Wars, or do you
Oh,
there's no AI in
sorry.
that, Star Trek? Do you like Westworld? Like what do you have any media you watch that there's AIs, whether it's realistic or not, that you enjoy?
Yeah. Okay. My end on a more positive note. The one of the Black Mirrors I like a lot, which is San Junipero, which is this. They basically make a simulation of Earth, so that as people die, they kind of get moved into the simulation, and it's almost like heaven in a data center, basically. So that's one of the few positive Black Mirrors and better vision for the future, maybe.
It is
I
positive.
like it. I'll have to check it out.
Yeah, I was gonna say you said Black Mirror and
It
positive, and I was like,
seems-
I
yeah.
can't think of any. But,
Yeah. Oh
no.
my God. You're hooked to paradise, but it's like the Matrix, right? You're hooked.
It is. But I guess the key is they're dying anyway. So this is like eternal, not the same as real life happiness, but it's better than just being, I guess if you don't believe in religion, just being dead and disappearing from the world. Their sort of digital twin is now in heaven.
It's like
positive?
It's like the retirement planet
positive.
from Futurama, where you get to go live in a digital world and relive all your best memories or something. But I mean, it's certainly more positive than I think a lot of media depictions are of where AI is headed or what people thought AI would be like whenever the thing was written.
Well, I agree. Like right now, I'd rather be in a parallel paradise world than living in the real world, for sure. Who knows what's going to happen? But I don't know. I feel like in these moments, I want to go back to reality, go back to the simple things that we forget about instead of like trying to escape to a non-real world. But I may be one of the few who thinks that anyway. Okay. Well, thank you so much. Do you have anything to add, Bob?
Well, no, we are at the end. And before we sign off, Brandt, was there anything that you wanted to plug? It sounds, I mean, we talked about some of the stuff you're working on. If there's a website or anything at all, feel free to advertise it before we end the stream and wrap things up.
Just if you want to get in touch with me, you can find me on LinkedIn. I also have a Medium place where I've published a couple little articles. But other than that, yeah, that's all.
Awesome. Well, thank you so much for your time. Thanks, Iman and Mandy, for leading the interview and having the technical knowledge to actually talk to Brandt about all the interesting stuff that he's worked on. I am going to start the raid over to the Real Good channel. So if you're watching on my Twitch channel, we're going to raid over just so you have a chance to follow. But don't forget, Real Good AI has a website filled with lots of information, including a place where you can sign up for the newsletter, a place where you could sign up to be a volunteer. We have a variety of volunteer groups ranging from our education outreach group to our machine learning scientific group to there's 5 in total? I think 4 or 5.
Four now.
4, and there are 2 meetings tomorrow for a couple of the groups. So if you're interested to support or volunteer, always you can donate.
Tomorrow, Saturday.
Tomorrow's Friday. Yeah, no,
Yeah.
Saturday. So you have time. You could sign up. Maybe you can make the meeting on Saturday. But yeah, there's lots of great stuff and information, and we stream every Thursday. So make sure you follow the Twitch channel. Make sure you follow us on TikTok. I'm going to send the raid over, so make sure you follow the raid and follow the Twitch. But thank you, everyone, for watching. Thank you for supporting today. Oh, I'm hearing my own voice in my ears. I love when that happens. And yeah, that's going to be it. This was really fun. Can't wait to see what startup you go with, Brandt, but I think you know which one I'm rooting for.
If you
Solve
have
all
a
my
startup,
problems.
we'll have another streaming with you explaining what you're doing in your new setup if this happens.
About that. Sounds good.
Okay.
Yeah, anyway, click on all the links in chat, below the stream, wherever. And we are out of here. Thank you, everyone. We'll see you next Thursday with another interview with someone new. But for now, thank you, Brandt, for sharing your time. And that's going to be the end of it. Bye, everybody.
Bye.